Alright, we're going to take a look at another problem here, zeros. So we're going to kind of use some of the different concepts that we've used in the last couple of videos, put all the pieces together, and hopefully come out with what we're looking for. Alright, so first things first, set this up to find all of our possible rational zeros. So again, we're going to find all of our factors of 8 for our p-values. So in this case, our values would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Alright, q values. Again, very simple in this one because our q values come from our lead coefficient and its factors. So in this case, plus or minus 1 taps us out. So again, on this one, real simple combination, because obviously anything divided by 1 is itself. So our possible rational zeros are just plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So that gives us all of our possible combinations to work with here. So we're going to set this one up, and I'm going to set it up using, like we've done before, our synthetic division. Now again, notice they're missing a couple terms here. We've got an x to the 5th, x to the 3rd, but no x to the 4th. So like we did earlier, we're going to have to remember to put that in as a placeholder. So there's our lead coefficient. And then here's our x to the 4th that's missing. X to the 3rd, x squared, x, and our constant. So again, we bring down our first coefficient. And this time I'm going to go right in order. So I'm just going to take positive 1 here, plug that in the outside box. So again, we multiply, add, multiply, add, multiply, add. So 1 times 1, add that up. 1 times 1, add that up. 1 times 2, add that up. 1 times 4, add that up. And 1 times negative 8, add that up. And there we go, we lucked out right away. And that's going to tell us two things. That's going to tell us that this is a factor of x minus 1, but it's also going to tell us that it's going to give us a 0 at x equals 1. So it does two things for us. All right, let's take this to another level now. Because we started with the 5th power, right now we're down to the 4th power here. So we still got a ways to go yet on this one to work it out. So we'll take this down. Now one thing that we talked about in the past was the possibility of double roots. In other words, it's possible that this 1 was a factor more than once. So we're going to put that in and give it a shot. So 1 times 1 is 1. Add those up. 1 times 2 is 2. Add those up. 1 times 4 is 4. Add those up. 1 times 8 is 8. And it worked out again. So just like that previous one, that tells me that 1 is going to come from the factor of x1. And if I set that equal to 0, x equals 1 is a factor. Now, for this one, that takes me down from 5th power to 4th power to 3rd power. So again, I still have a little ways that I can take this. So we're going to go down one more step at least, because if I can get it down to quadratic, then I have a lot of options on how to get my final couple of parts done. Alright, so now that we found a couple just by a little guess and check, I am going to cheat again here, just for the sake of saving time. I know negative 2 works because I've looked ahead. So negative 2 times 1 is negative 2. We're going to add those two values. 2 times 0 is 0. We're going to add those two. And negative 2 times 4 is negative 8. So we're going to add those two up, and we get 0 again. So again, that's going to tell me two things. Negative 2 came from the factor x plus 2, and if I set that equal to 0, I get x equals negative 2. So right now I've got 3 different functions or factors. This is telling me that I could have up to 5. Now again, our goal was if I could at least get this to a quadratic. So right now, this part that's left, because this was x to the 5th, x to the 4th, x to the 3rd, now it's x squared, plus 0x plus 4. So now once I've got this, I can actually take this and set it equal to 0 and solve it. So let's do that. So I'm going to subtract over here and get 4, and then that's going to lead me to finding the square root of this and plus or minus the square root of negative 4, and I'm going to actually end up with plus or minus 2i for my x's. So now when I can go up here and I can write my final solution for this as a product of linear factors, I can just say f of x equals x minus 1 times this x minus 1 times x plus 2 Now remember here, positive 2i would actually be coming from x minus 2i as a factor, and negative 2i is going to be coming from x plus 2i as a factor. Now again, how do I know they're linear? X to the first power, first power, first power. They're all first degree binomial. So this would be the first thing they were asking us to find with the product of linear factors, and then to find the zeros. We kind of started that already if I set each of these things equal to 0. So I would actually have x equals 1, x equals 1, x equals negative 2, x equals 2i, and x equals negative 2i. So these are my zeros. So a little bit of extra work to deal with on that one. We were finding 2 different setups here. We were finding the product of the linear factors. We were finding the zeros, but we combined a couple things. Finding possible rational roots, using synthetic to shorten up our division, and taking us all the way down to solving a quadratic formula to get 2 roots. Now remember, if you're using synthetic, it worked out nice because this has been worked out ahead to save time, where I always did happen to end up with 0. And remember from our factor theorem, if we got 0 as a remainder, it meant what was out front got us a factor. Now if I would have done this, got a 0, did it again, got a 0, maybe I thought, hey, is it a triple root? And put 1 again and didn't get a 0, the part in blue down here, I would have to start over from where I left off in the part in green and find another value from up here to plug in and solve with. So that's another step that I can look at here and try to solve to get solutions like we got over here.